Dear students, in this lecture we are going to study about the another type of phase comparators, that is called the coincidence type phase comparator, and second one is the integrating phase comparator. In previous classes we have studied about the another type of amplitude comparators and phase comparators. Here we are further classifying the phase comparator in another form, and one of that is the coincidence type phase comparator. The concept of coincidence phase comparator is that sometimes it is required to compare two signals when there is a coincidence, but this coincidence will change depending upon the phase difference of the two signals. If we vary the phase difference between the two signals, then the coincidence period will be also varied. So depending upon the coincidence period, we can generate the output trip command so that we can protect a device. That is how the coincidence type phase comparator works. So the basic concept of the phase comparison is simpler in that it is possible to deal with signals of equal strength whose coincidence or non-coincidence is readily measurable. We can apply where the coincidence or the non-coincidence between two signals is measurable. Let us see, considering in this diagram which has been shown here. These are the two diagrams having a signal S1 and S2. S1 and S2 has been shown here. So considering two sinusoidal signals S1 and S2, the period of coincidence of S1 and S2 will depend on the phase difference between S1 and S2. Already I have told you that the coincidence period will be varied depending upon the phase difference between S1 and S2. As figure illustrates the coincidence of the signal for different phase relationship in coincidence type phase comparators. Let us see here for this phase difference. Let us say S1 is, this is the for positive half cycle, and S2 starts from here, that is for the positive half cycle. So this is the phase difference, this is the phase difference. Now if you vary the phase difference, it means this signal will start from here. Once this signal starts from here, then the signal will lie something like this. So it means the coincidence will change. Now this portion will become the coincidence for in this case. So that's why it has been told that the coincidence periods vary depending upon the phase difference between two signals. And if you are able to measure this coincidence period between two signals, then we can decide that for what duration we can generate the trip command so that we can protect a power system network. That is how the coincidence type phase comparator works. Now in this case we will discuss about the another type of phase comparator, that is called the, now let us say here it can be seen that the period of coincidence is equal to the period of non-coincidence for a phase difference of plus minus 90 degree. The period of coincidence is less than the period of non-coincidence, and vice versa when the phase difference is less than plus minus 90 degree. So already as we are saying that if the coincidence speed, suppose this is the phase difference something phi, and this from here to here, this is the coincidence period. So what is telling here that if you vary the coincidence period, that is if you vary the phase difference plus minus 90 degree, then coincidence period will vary, and depending upon the phase relation of the input signals, it is possible to design the circuit to give an output either a yes or no by measuring the periods of the coincidence type of phase comparator. So for obtaining the coincidence, we use the different methods. The different methods of obtaining useful characteristics as shown below. The first one is the block instantaneous comparison, in which the duration of polarity coincidence determines the output. The tripping criterion is that the duration of the first coincidence should exceed a specified time, usually 1/4 of the power frequency period. So in this case, the block instantaneous comparison, we can have a coincidence comparison, and second one is the pulse comparison. In this pulse comparison, the polarity of one signal is measured during a short interval in the cycle of second signal. Let us say this has been shown in this diagram, that if we are having a voltage and current, and we are applying this voltage and current to the measuring and mixing circuits, where again we have a two output, V1 and V2. So V1 is going to the coincidence circuit, where this coincidence will be compared, and the output from this measuring circuit V2 is applied to a pulse circuit, and output of this pulse circuit is applied to the coincidence circuit, where this coincidence period will be measured, and accordingly we give the trip command. So what has been shown here, that when we have a V1 positive and output from the pulse circuit V2 is also positive, then in that case the coincidence for these both positive signals will be compared, and it will give a command whether a trip or the stream. So what we say here, the voltage V2 is applied to a pulsing circuit which produces a positive pulse once every cycle. V1 and pulse derived from V2 are then applied to the terminals of the coincidence type phase comparator circuit, and when both input becomes positive, it gives a potential change at its output terminals. That is how we can operate the coincidence type phase comparator by having this circuit diagram, in which we have a pulse circuit applied, so we can have both signals either in positive polarity or in negative polarity, and that can be applied to a coincidence circuit. So this is the second measurement of circuit of the coincidence type phase comparator. Now next type of phase comparator in this category is called the integrating type phase comparison or phase comparator. So what we do actually in this type of phase comparator, as in previous case we have studied that we can measure a coincidence period between two signals, and this coincidence output, that is the output of the coincidence circuit, is applied to a linear integrator which ensures the linear rise of the output quantity, and further it is applied to a level detector, which ensures that the magnitude of the input is reached to a preset level, and as soon as it reaches to a preset level, then the output is initiated either in the trip form or in the restraint form. That is how the integrating phase comparator operates. So what this comparator says, in this method, the time overlap of the two sinusoidal inputs is measured for each cycle by integrating the output of an AND gate through which they are fed. The period of coincidence is measured, and only if it exceeds 90 degree for a symmetrical comparator, the output is obtained. So that the condition is given that theta is plus 90 degree and minus 90 degree. This is the condition of the coincidence period. And next is, in this type, the period of coincidence are integrated and then fed into the level detector, the critical operating threshold of which occurs when the periods of coincidence and non-coincidence are equal, that is theta equal to plus minus 90 degree. So as I have told earlier that the output of the coincidence circuit is fed to the linear integrator, and from there it goes to the level detector, which determines the output command, and the condition determines here the coincidence period can be measured between theta equal to plus 90 or minus 90 degree angle. So this is called the integrating phase comparison. If we have two signals S1 and S2, so how again they will have a coincidence period, different phase relationship of signals are shown here. For example, see S1 and S2, there are two signals, so here we have this much phase difference, here we have a very less phase difference, and here again we have a in between, that is more than this and less than this, the phase difference, and depending upon these phase differences, the coincidence will occur, and this coincidence will be applied to the operating circuit. So what it says that the input quantities S1 and S2 are connected in a coincidence circuit, producing standard output pulses which are positive when S1 and S2 are of the same polarity, and negative when they are of opposite polarity. The pulses are applied to an integrating circuit whose output increases linearly during the time when pulse is positive and falls at the same rate when the polarity reverses. The level detector switches when the integrator output exceeds some preset value. As already I have told you that there is a preset level is determined in the level detection circuit, so that if the input quantity is reached to that set value, then it will give the output. So the integrator output exceeds some preset value, then it will be switches, and it will reset when the output falls below some another value. That is how the integrating type phase comparator operates. Now this is the another circuit of integrating type phase comparator, which have a diode with rectifier, polarity detector, RC charging circuit, level detector, and after that there is a output. So here we have two signals of the current I2 and I1, which are fed through these rectifier circuits, and from there the output is taken to the polarity detector. So what see that another integrating type of phase comparator uses a rectifier, bridge and gates. This is the rectifier circuits and gate circuits. So this, that's why it is called the another type of integrated phase comparator, which consists of this rectifier, bridge and gates. Rest, I think RC charging circuit has been added further. Otherwise, polarity detector and level detector, they are common in all type of phase comparators. And after that, we have an output. So, what is the advantage of having this type of circuit for the integrated type of phase comparator? That this has advantage in its simplicity and economy. This is the advantage of this type, having this type of circuit. Secondly, this uses a rectifier bridge with a consequent polarity detection circuit. So, because of the rectifier and gate circuits, this will be able to identify more sensitively what is the polarity by the polarity detector. And when the polarity is determined by the polarity detector, it will be fed to the RC charging circuit and then level detector, and further it will go towards the output. So this is how the integrating type of phase comparator is working, and it can be utilized for the production circuit. So here in this lecture we have discussed about the coincidence type phase comparator and integrating type of phase comparator. Both comparators are the part of the phase comparators. So in previously I have discussed the various types of amplitude comparators, and in this class we have discussed the various types of phase comparators, how they are working. So this is the end of this lecture, and further we will discuss in another class. Thank you.